In this session, we will see how to synthesize 4-bar mechanism for 3 positions using inversion method. I'll read the problem statement. Initial inclination of crank, that is input link, is given as 40 degrees. Angle between first and second position of crank is 35. Angle between first and second position of output link is 50 degrees. Angular position between first and third positions of crank is 80 degrees, and first and third position of output link is also 80 degrees. Length of crank is given as 2 centimeters and length of fixed link AD is 8 centimeters. So we will invert the mechanism on link number 4 in its first position. So for that, first of all, we draw the fixed link AD having length of 8 centimeters. So this is fixed link AD with length of 80 centimeters. Then we draw crank of 2 centimeters in its first position, which is at 40 degrees from the fixed link. So at 40 degrees, I have drawn the first position of the crank AB. Now the angle between first and second position of crank is specified as 35 degrees. So we draw the second position of the crank. From first position it is 35 degrees. We take the angle about A this way. This is 35 from the first position. So this is the crank in second position. I will name it as B2. Now we will draw the crank in third position. Now angle between first and third position is 80 degrees for the crank. So from first position it is 80 degrees. So this is the third position of the crank. I will name it as AB3. Okay. This is 40 first position. Angle between first and second position is theta 1 2 35, and angle between first and third position is 80 degrees. Next we join point B2 to D. Join point B2 to D. We will rotate this point B2 about D like this. In reverse direction by an amount of 5/2. Okay. Angle between first and second position of output link is 50 degrees. We are inverting on link number 4 in first position. So we will reverse this line DB2 backwards by amount of angle 50 degrees. So this is 50. We get inverted position of point B2. I will name it as B2 dash. Okay. And this angle is minus 512, 50 degrees. Next we join B3 to D. Next we join B3 to D. And we will rotate this point backward by an amount of 513. Along this path we will rotate B. 513 is 80 degrees. So we will rotate this line backward by 80 degrees. So here is 80 degrees. So we get point B3 dash. So we'll name this point as B3 dash, inverted position of B3. In the next step, join point B2 B2 dash and B2 dash to B3 dash. Then we'll find out the midpoints of these chords. B2 dash to B3 dash is 68 millimeters. Okay, so its half is 34. So the center of this line lies at 34 mm. Now we draw one perpendicular at this midpoint of this line. Okay, we'll draw one perpendicular at this midpoint. We'll extend that perpendicular. This is the mid normal to chord B1 dash B2 dash. Next we find midpoint of B2 dash B3 dash. Total length is 4, so center will be at 2. Now at 2 we will draw perpendicular to this line B2 dash B3 dash. We'll extend that mid normal to intersect the mid normal of B1 dash B2 dash, and these 2 points will intersect at point C. Okay. Next we join C to D and A to C. B to C. Okay. So ABCD is the required 4-bar mechanism. Okay. So this is link number 2. This is coupler link number 3, and this is link number 4 CD, and fixed link is link AD. Take length of coupler link as L3 and length of output link is L4. We'll measure the length of coupler link L3, it is 12 centimeters, and length of output link L4 is 5.7 centimeters. Hence we have determined the dimensions of coupler link and output link from the given 3 positions of input and output links using inversion method.